Hello and welcome to the briefing brought to you by Cyber Team 1. Today is August 8th, 2026. In the next 10 minutes, we'll cut through the noise and bring you the cybersecurity intelligence that matters most to business leaders and defenders. Everything we cover today comes from the past 7 days, and there's a single thread running through all of it. This week, attackers went after the machinery that builds and ships your software. Not your customer database, not your website, the pipeline in between. The build servers, the code libraries, the automation tools your developers rely on. That machinery holds the keys to everything else, and in most organizations, nobody guards it the way they guard production. Let's start with the biggest one. On Tuesday, attackers took over the account of a software developer who maintains a handful of small, unglamorous code libraries. Names you've never heard of: Keyv, Cacheable, Flatcache. These are the plumbing of modern software, the small pieces that thousands of other programs quietly depend on. Keyv alone was downloaded more than 600 million times last month. The attackers poisoned those libraries, and then they did something clever and nasty. They planted a worm. Once it landed on a developer's machine, it hunted for passwords and access keys, and when it found one that could publish new software, it used that key to poison more libraries automatically. In under 4 hours, more than 400 packages were compromised. Elastic Security Labs, who spotted it the same day, put the total reach at over 1.3 billion downloads a month. Now here's the part that should make you sit up. Normally, this kind of attack only fires when someone installs the software. So the advice has always been simple: be careful what you install. This one is different. The attackers also planted instructions that run when a developer simply opens the folder. Not installs it, opens it. If your security researcher clones that code just to have a look at it, the attack has already run before they've read a single line. And what it steals is exactly the set of keys that lets your organization ship software. Cloud credentials, developer access tokens, encryption vault keys, server login keys. On some systems, it even reads secrets straight out of the memory of your build machines, where they never show up in a log file, so nobody would ever see them go missing. For executives, the question here isn't technical, it's this. If every password on your developers' laptops disappeared today, what would you have to change and how long would it take? Most organizations have never asked that question, let alone rehearse the answer. And if you publish any software yourself, there's a second question. Would you notice if someone released a version under your company's name that you didn't approve? The practical fix is unglamorous and effective. Upgrade to the latest version of the software installer, which blocks the risky behavior by default. Turn on two-factor authentication for anyone who can publish. And introduce a waiting period before your teams adopt brand new versions of anything, so the wider community has time to spot problems before they reach you. Next. A serious flaw in a widely used build server called TeamCity is now being actively exploited, and American federal agencies were given a deadline of today to fix it. A build server is the machine that takes your developer's code and turns it into the product your customers actually run. To do that job, it holds the credentials to sign, package, and deploy your software. Which means an attacker who gets onto your build server doesn't need to break into production at all. They can simply wait for the build server to deploy for them. The timeline here tells the whole story. The vendor disclosed this on July 27th and said at the time they weren't aware of anyone exploiting it. 9 days later, American authorities added it to their catalog of vulnerabilities under active attack and set a 3-day deadline. That's the entire life cycle of a modern critical flaw, start to finish, inside a fortnight. If you run this product on your own infrastructure, and it was reachable from the internet at any point in the last 2 weeks, don't treat this as a patching task. Treat it as an incident. Rotate every credential stored on it and check what it built during that window. In another development, and this one's genuinely novel, researchers at a firm called Novi tested the AI coding assistants made by Anthropic, Google, and OpenAI. Not against a made-up target, they tested each company's own assistant running on each company's own code repository in the exact configuration that company ships to everyone else. They found that a stranger with no permissions at all could file a bug report, and that bug report alone was enough to run their code on the company's own machines. On 2 of the 3, it also exposed live access keys. Google rated its flaw 10 out of 10, the maximum severity that exists. Here's what makes this worth a board's attention. None of these companies were careless. One of them runs 23 separate security checks on every command. The failures happened at the handovers, where one piece of software decides something is safe and hands it to another piece that then acts on it with more authority. Each individual decision was correct. The combination wasn't. And that's the real lesson. When you deploy an AI agent into your business, you're not just adopting a model, you're embedding somebody else's software into your infrastructure and inheriting thousands of decisions their engineers made about what counts as safe. Most of those decisions are undocumented. Some are built so deeply into the product that no setting you control can change them. All 3 vendors have patched, and there's no sign anyone has used these attacks against a real target. So the work here isn't emergency response, it's inventory. Find every automated process in your business that an outsider can trigger. Work out which AI tool runs inside it, and check what permissions that process carries. If an outsider can start it, it shouldn't be holding the keys to change your code. 2 more, briefly. A flaw in Apache Tomcat, one of the most widely deployed pieces of web server software in the world, is now being exploited by 2 separate groups, and one of them is running an AI system as the attacker. Researchers at Palo Alto Networks documented an operator who pointed an AI model at more than 460 targets. When one attack failed because the target was well configured, the AI went and researched other ways in by itself and picked a different flaw. Most strikingly, it appeared to narrow its own target list to save on computing costs. It made a budget decision. That changes the economics. If an attacker can spend computing power instead of analyst hours, they'll attempt far more targets than before. Which means any organization whose protection has quietly depended on being too small or too obscure to bother with should revisit that assumption. There's a second lesson in this one. The Tomcat flaw exists because the fix for an earlier flaw was incomplete. That's now the 3rd example in 2 weeks. So when your teams report something as patched, it's worth asking whether they confirmed the weakness is actually closed or simply recorded that a version number changed. And finally, a quieter threat that's worth knowing about. Arctic Wolf reported yesterday on a phishing campaign that's stealing access to Microsoft 365 accounts, and it's built specifically to avoid detection. The attackers use a fake sign-in page that sits between the victim and the real Microsoft login, capturing the password and the security code as they're typed. Then they log in from an internet connection in the victim's own country, so nothing looks unusual. And then they do almost nothing at all. They don't change the password, they don't add a device, they don't set up mail rules. They just quietly read the mailboxes of people who handle payroll and finance at 8-hour intervals automatically. Because the goal is to learn enough to redirect somebody's salary payment into an attacker's account. Every behavior that security teams have been trained to detect was deliberately left out. The defenses that work here are specific. Phishing-resistant sign-in methods, the kind using a physical key or a passkey, because those can't be captured by a fake page. And a simple business rule: nobody's bank details get changed on the strength of an email alone. So, to wrap up, 5 stories, 1 message. Your software supply chain and your build infrastructure are production systems. They hold production credentials and production authority. But in most organizations, they're governed as developer tools, which means they don't get the inventory, the access controls, the monitoring, or the scrutiny that everything they touch receives. That's a scoping decision, not a budget problem. And this week gave you 5 separate reasons to revisit it. 3 things worth doing this week. Check your build servers are patched and rotate what's stored on them. Find out whether the compromised code libraries reached your developers. And take the right access away from any automated process that a stranger can trigger. That's it for this edition of The Briefing. Stay alert, verify the facts, ask the hard questions, and we'll see you in the next one.